With the Genesis sculpture, we have already demonstrated our ability to reduce the weight of structural components, and now we want to show that we can also reduce the weight of the exterior, surface parts and trim panels. And the question we asked was, how would nature do this? If we look at the leaves of a plant, we can see certain load-bearing structures, a network of veins covered by a skin. And why shouldn't this principle also be the solution for a car bonnet, for instance? The trick is that, by regarding the bonnet as a volume part instead of as a sheet metal part, we might be able to reduce the density of the material, removing everything not needed for dynamic and static load cases. What we would then end up with is a three-dimensional, load-bearing skeleton that complies with all the static requirements imposed on a bonnet, without a skin. This was topologically calculated. Of course, rain should be kept out of the car, and we need a surface for its aerodynamics. So all we need to do is cover the load-bearing skeleton with a skin, and in doing so have in fact transferred the design principle of the leaf to the bonnet. By today's standards, the use of a fabric would be the lightest alternative. There are fabrics that weigh less than 19 grams per square metre. To compare, standard copier paper weighs about 80 grams per square metre. This would make our skin 4 times lighter than paper. In our search for a weatherproof stretch fabric, we came across outdoor specialists Jack Wolfskin, and they immediately agreed to join us in our quest. Thank you, Jack Wolfskin. The fabric covering, of course, also helps us to visibly display the vehicle's central statement, because we can pass light through the fabric, which displays the bionic substructure and also enables us to apply lighting technology to brilliant effect when exhibiting the concept. The stretch quality of the material also makes it possible to follow the organic physical movement of a rear spoiler without the detraction of the joints seen in today's production models.